Bismillah ar-Rahman ar-Rahim. This is teacher Iman al-Khaldi explaining counting principle. First, we are going to focus on factorials. And let's know the definition of factorial for positive integers. Actually, factorials, which is n, belongs to z positive, is going to be written in this way: n and an exclamation signal beside it, which we can read it as n factorial. And we can define it as a product of consecutive whole numbers started by n and ends by 1, by starting by the biggest, which is n, then reduce it by 1 to get n minus 1, then n minus 2, then end it by 2 and 1. Or you can write it in an opposite way, like this exactly. n factorial equals 1 multiplied by 2, 3, then you can end by n. So the biggest factor is going to be this n, and the smallest factor is going to be 1. And we should write it as a product of consecutive. This is the definition. We can have some examples, like, for example, if I will have 6 factorial, this can be written as 6 multiplied by 5 multiplied by 4, then 3, then 2, then 1, or the opposite. Then you can evaluate them to get 720. Let's go to the second idea, which is how to expand of factorial into an arithmetic progression decreasing by 1 unit. Like, for example, if I have n factorial, I can write it as n and take what is before, which is n minus 1, and keep its factorial with it. That means n minus 1 goes with the multiplication reduced by 1 till 1. But no need to write this all. It's enough to write n minus 1 factorial. Or you can start by the first factor, which is n, then the next factor, which is n minus 1, then n minus 2, and stop with the factorial. That means you are going till 1. Or you can reduce it by writing 3 factors consecutive: n times n minus 1, then n minus 2, then the fourth, which is n minus 3, keep it with the factorial. You can have this n multiplied by n minus 1 and n minus 2, n minus 3. As you would like to write factors, you can expand it. And that means you're gonna stop with somewhere with the factors, but keep it with the factorial if you don't want to go to 1. And that can help you to simplify some equations. Now the next step is, if we want to know how to regrouping the factorial by writing n plus 2, for example, multiplied by n plus 1. If you're gonna see this in your questions, you are going to think about which one is the biggest factor. So the biggest one is n plus 2. That's mean I can tell you the story of the small fish which gonna be swallowed inside the big fish. So let this n plus 1, which is the small fish, gonna be swallowed inside the biggest fish. So it will disappear. So n plus 2 only, which is the biggest fish, gonna appear. Now, if we have 2x, for example, multiply by 2x plus 1, then 2x minus 1 factorial, let's focus on the biggest fish, which is 2x plus 1. So that's it. So we are going to keep it only outside because it's gonna swallow all that small fishes. Now, if we have 5a, also, if we have 5a multiplied by 5a minus 1 and 5a minus 2 and 5a minus 3 factorial. They are in order, and the biggest fish is going to be 5a, which is the biggest factor, and all small fishes will be inside her abdomen. This means these all will be swallowed by the biggest fish, and that will keep only the biggest one, and others will disappear. Be sure that the bracket is written here with 5a factorial, because that will be different if you are going to write 5a without bracket. It is going to be different completely, because that means 5 is outside the factorial series. So we're going to write a times a minus 1, and this is the series of the factorial of a without including 5. But in that up, we are including 5 everywhere. Here, to continue, we have to write a minus 2, then times, till you are going to get something smaller. And that's it. Let's go now to the next, which is this note, which is telling you that here together, these together, this box and this box is talking about something very, very important. We can focus on the factorials of the first 9. Let's start by it here. The factorials of the first 9 whole numbers. We said 9 whole numbers, which are from 0 till 9. So the factorial of 0 is going to be 1. And there is improvement for this. We're gonna discuss it later. And here 1 factorial is gonna be equals to 1. Because we are going, according to the definition, multiply 1 once. 2 factorial will give you 2 times 1, which is going to be written in this way, 2 times 1, which is 2. 3 factorial means 3 times 2 times 1, which is 6. 4 factorial means 4 times 3 times 2 times 1, which is 24. 5 factorial means 5 times 4 times 3 times 2 times 1, which is 120. 6 factorial means 6 times 7, 6 times 5 times 4, 3, then 2, then 1, which is 720. 7 factorial means 7 multiplied by 6 by 5 by 4 by 3 by 2 by 1, and 8 factorial similar. So, or you can, for example, have 5 factorial by writing 5 times 4 factorial. It means 5 times 24. And that will give you the same answer, which is 120. Then you can compare what we discussed now with this box. We said that notes, and they are very, very, very important notes. Saying, and let's label them, number 1, 2, and 3. In the first note, we can notice that if we have a is a factorial equals to a, that means this number is similar to that number. According to this table, you can find it at 1 and 2, like this. 1 factorial will give you 1. And also 2 factorial will give you the same 2. So the answer will be then either a equals 1 or a equals 2. In the second, we can say if a factorial equals to 1. Go back to this table and you can see that you can get 1 here only and there. You can get 1 here or here when we have 0 factorial or 1 factorial. So the answer is telling you that either a equals 1 or a equals 0. And if we have a factorial exactly equals to b factorial, and a and b belongs to natural star, this means without a zero, then a should be equal to b by canceling factorial from here and there, and that will give you a equal to b. Now we are going to go to the next table, which is this one. Here, don't in factorials. Don't do this in factorial. We can say that for any two whole numbers, a and b, notice the following. We can see that if we have, for example, a factorial added to b factorial, it won't be equal to, if you add them, then do their factorial. Let me give you numbers. For example, if I have 2 factorial plus 3 factorial, that will give you from the left side 2 plus 6. According to what do we have here? 2 plus 6, which will be 8. So this all will give you 8. But in the other side, if we add them, like 2 plus 3, you will get 5. And if you're going to find the factorial of 5, it will be 120. And they won't be equal. So you can't say that they are equal. Similar, if we have it added like this, we can't split it to be a factorial alone plus b factorial. And similar in subtraction, similar in multiplication, we can distribute them. And similar in division, we can distribute division to each. So the last box is saying some examples of arithmetic progression decreasing by 1. Like, for example, if you have n plus 2, what is before? N plus 1, because you have to think about 2, then 1, then 0. And that will be written as n alone. Then minus 1, then minus 2, and go ahead. Here 2x plus 2, and what is before 2? It is 1. So it will be written as 2x plus 1 and 2x alone, which is plus 0, then 2x, then 2x minus 1, then 2x minus 2. Here you have to start by the biggest also, 3a squared plus 1, and before 1 is 0. 0 is not written, so you have to write 3a squared without anything, then minus 1, because you are reducing by 1, with keeping the same factor here, 3a squared minus 1, the same form of the factor. Now we have to read the last box, which is talking about for any whole number. And these whole numbers are 0 till 9. If we're going to say that in factorial, it's going to be equals to, if you have n plus 1 factorial and divided by the same, but without factorial, you can get in factorial. Let me give you numbers. Like, for example, if I have 6 factorial divided by 6, that means I will expand up to give you 6 only, which is the first factor, multiplied by 5 and leave the factorial beside it. That all divided by the 6, which we have it down. Now you can cancel these 6 up and down together. And what is left? You can have 5 factorial, like this. So this is the answer, which is 5 factorial, like this. Now let's have an example, another example, which is like this. If you have 7 factorial divided by 7, that will give you 6 factorial. This is a short way to simplify such thing like that. And that can help us to prove the 0 factorial, why it is 1. by thinking about this 0 factorial is exactly that number, if we plus it by 1 and if we divide it by the same. That will give you 1 finally. If you add 0 plus 1, it's 1 factorial. And 0 plus 1, it's 1 again. So that will give you, if you divide them, 1. So this is a good improvement to tell you that 0 factorial is equal to 1. Like this. Thank you for listening. Good luck.